Okay, so I, I just hope that you people can hear me. So I I think I've dropped two videos as touching this thing I'm hearing, right? So this is kind of um what is it called? This is the let me put it in edit. So this is just the workflow. And I call it workflow. So this is kind of the workflow actually. Uh, I don't know what I'm doing. So this is the workflow. This is the workflow. I hope you can see it. So this is workflow, right? And this is just basically what it's doing. So from getting a queue job to inputting it in a PostgreSQL job table, skip log, skip list, if there is an overtime of workers attempting, you insert job attempt, and if successful, you declare successful. And then if it fails, you can retry, or you can go to deadlock, or can be quarantined, or you can back off, like policies surrounding it. I just want to use maybe a very basic analogy to explain what these things are about. So this is just like um, it's just like a company that have developers, right? Um, I mean, just for people that don't understand, so this is just like a company that have developers, and these developers um, are sort of the workers I'm talking about, and the company is just like the database, which is PostgreSQL. So um, this this company gets work the from clients, right? Then developers, which are the workers, will now come and take work from the company they are working for, right? And after successful working, they will deliver that okay, I've successfully worked this on this. And there cannot be two developers that are working on one job, right? And maybe for any reason a developer started the work and didn't finish it because of sickness or whatever, right? The platform or the company can take that job out of from the developer and give it to somebody else. That's just this is just what it is all about. So this is a Postgres queue flow. I call it Postgres flow actually, and people call it background worker, right? Generally. So um, this is what I describe is just the core of it. So there are some policies around it, timeout, retries, backup, um, quarantine, um, dead letter, and stuff like that. These are maybe policies around it. I'm just trying to explain what it is, right? I I want to see if I can just explain this first flow that talks about the queue. So getting job from the queue into the Postgres job. So I will zoom out from this a bit and zoom into this. Right. I wish I can really have a laptop here, something I can use to write. Um, I don't know if I can have such here, but let's just do some. So this is where I want to zoom into, and this is where I want to stay. Right. So how can a job come or go from the API or from the client, right, to this man, to the company I talked about, to PostgreSQL, to our database, right, which is our source of truth. How does it happen, right? So let me just zoom into this place. So this is the workflow for this. Right. We have a queue guide, and what this queue guide is doing specifically is that is trying to filter out something for us. It's just kind of a gateway, right? Maybe that moment you want to enter a plane, right? You want to enter an airplane. You might be asked to weigh your load, right? Um, and there will be a queue, right? everybody cannot be wanting to enter the plane at the same time, right? And if your load is more than what the plane can carry, it should be dropped actually, something like that. Do you get? Uh, so it's not even in Nigeria where you want to enter, but when you can, you put load that the back of your car will just be touching the floor. But so this is just what you want to do. This is just what I want to explain. Actually, um the code already is working. Right, I think this Zoom is good enough. So this is my structure. So the code already is working. So this is what I want to explain, because this is where everything is coming from. And I've talked about the config file. I've talked about the. So this is the um the guy that handles or that makes sure that we get an ordered or a good request or a good job, right? So this is the man in charge of it. And so this is what I really commented out here. What I just explained here. This is just what it is, right, basically. And so these components, what they do, this component, so this actually handles this UTC talks about the current time, right? And I mean, we should actually be familiar with this. So this talks about this is a threat that you want to just get the second method of it. So this talks about the time, the full time stamp, the time zone we are. So this is just Sade, we know Sade now, the almighty structurer. This is PG flu that connects us to the DB. And so this one here, now this background worker, one of the rules that I actually try to implement or I try to enforce is to make sure that no error happens in silence, right? There should be a reason why an error happens. It should be detailed, right? It should not be something that is in the air, right? So this is what this ingest ingest decision is doing, right? That's why we imported it here. We have actually defined it inside of our job repo here, right? Look at it. This is where it is. This is it here. But that's not what we are going to talk about actually. Um, so this is where we defined our structs, right? We defined our structs, the use size and the unsigned unsigned the signed integer. Sorry. And so this is where we instantiated this struct. To instantiate this struct. So this struct now, this is what it's doing. Right. The payload here, the max payload is what we defined here. And um, what this is just saying that we just need um 1,000 Q, 10,000 Q per minute, right? And so this is why we imported these guys here to help us achieve that. So we are trying to calculate per minute, right? So we are saying that in this transaction, in this queue, we can only have um 10,000 Q per minute. So anything more than that, we return an error message with the reason why this error message happened. Right, so that's what this is doing. Um, and so this is where we actually declared um, um, our imports. Right, this is where we declared it and we'll be using it. Right, um, this is where we declared the structure actually for it, and we instantiated it here. Of course, you know that was on instruct when you declare this here, there's only the repeating yourself up and down, right? Um, so you can still do something like dot dot, declare this stuff, but it's not really necessary. So what we are doing here is just we are trying to make this invisible, to be able to tell the API that okay, this is the max you want to use, right? And so remember we declare this max here. Um, and declare this max here, which is by default is 256 KB, right? So we are saying that the payload here is the max is what it is. We declared the return of it payload. So that means that anything above this is not accepted, right? And so this is where you want to check our payload, right? And this payload is going to return is not returning, is returning an error or a success message. So this success message, you're not really expecting any data, right? You just want to know that this thing was successful, right? That's what this thing is. So we are saying that if um payload byte is the payload byte that we want to the request that we are getting is more than what we have actually defined here, right? We have actually defined here. Um, if it's more than it, we want to actually throw an error. We want to return an error. So this is saying return an error, or this is saying we are not really interested in the error. But since we have actually imported the decision here, that means we are expecting an error or a success message, right? So if for any reason this the payload we have is greater than what we've defined here, so we are expecting the queue name, the name of the name of the queue, right? And the decision is just that you're denied. Why? The payload is too large. And we try to tell you, give you details why. So the max payload we actually define in our system is this, and what you have is this. So I think this is a good information to help the client, or to help a developer to be able to understand what is happening nice than silently ignoring the errors, right? Um, for someone that doesn't know, they might take a lot of time looking for different files, while this simple return message can actually tell you where the error is exactly. So these are ways you just shall know what this are ways is doing. You're waiting for this thing to run. So if everything goes well, if this is equal to this, or is less than this, right? This will return and continue. If not, if there's any error anywhere, just return it immediately. But if this thing was the message concluded message, just return this, right? And so if everything went well, right, just give us a successful message. And now here is trying to check the time, right? The time here we are talking about is per minute. So you are calculating, you want to have a certain number of queue per minute, right? And the queue we want to have per minute is 10,000, right? And so this is also returning this, is returning an error message or nothing, which in nothing now is successful, right? So we defined our UTC, and UTC just telling us the current time, and this Windows state, this is a variable that has this, right? So what this is doing is that this is a construct that wraps this main here, right? So what this is doing is just this gives us the full time, right? It gives us the full time with the time zone, right? But we are calculating per minute. So we are looking for a way to remove the seconds from the minutes and hour, right? So that's what we did here. So we actually received the time, and we subtracted the seconds from the time, right? And then if for any reason there was an error, which is a rare case, it's a rare case scenario, just default to this. That's what this is just saying, right? And then this is really where maybe we have to maybe want to pay close attention, because this is a little bit um technical. And I think every other place is very, very simple. So now this is saying that, so this is a variable, right? And this variable is trying to start a connection for us, right? And this connection is a transaction connection, right? So you are saying start a connection. So this await here is waiting for the connection to be established, right? This transaction connection to be established. If there's any error, this is why this question mark is return the error immediately. If there is none, just continue. And so when the connection is established, you want to insert this enqueue rate count. So this enqueue rate count is now this queue here is the name of our queue, right? Now, what this is doing is just that you're actually inserting unique values, right? Unique values. So in our case here, you're inserting a queue and a window state. So the window state is the actual time that this queue was available for us, right? And this count is just kind of an incremental count, right? So this is kind of saying this is creating a row for us, and in that row we have we have a unique a queue. So the queue can be an email, it can be a webhook, it can be anything, right? And that queue should actually have a way which we have actually described here. We can capture the exact minutes that this queue arrived, right? And also store the count. So we should be able to store the count of this queue. And then um so for any reason this queue already exists, the queue coming in, the row already exists. So instead of maybe panicking or returning an error, we are just telling this SQL to just update the count. So update the count from 1 to 2, then return the count for us. That's what it's saying. And then um this is now trying to run this SQL inside of our current transaction, right? That's what it's doing. So this fetch underscore one is just you're saying run this SQL inside our PostgreSQL, but in this our open transaction. So I commented here that the SQL now I want this mute here was actually used for a reason because SQL treats the transaction as an executor, right? And then running a query through a transaction requires mutable access to that transactional update. So because transaction are internal state that is used and advanced. So this to make it to be very, very simple, think about it like um let me just use this context to explain it. So this is updating something inside of this, right? Remember we declared this thing here. So this is what is running, this is where everything is running, right? And this is a variable, right here. Now this is running everywhere. This is updating, right? Is updating if there is anything wrong with this. If there is if the queue that is coming in already exists in our um, record, just update. The updating happens. Because the updating we need a mutable reference. So we don't want to own this data, but we want to actually have access to modify it or do any modification or run any stuff on it. That's basically what it's saying in this context. But in a large context, SQL needs when you're running transaction on that in SQL, you need a modification because it gives it access to do what it wants to do. That's basically what it's doing here. Right. If everything goes well, this is just awaiting the result. If everything goes well, because it's waiting for um a, a return count because we stated um a returning count here, right? We are saying that if the count is greater than the count return is greater than what we specified here, which in our case is 10,000, then make your decision and return this, right? I think we will explain this since similar with what we explained our goal. Then when everything happens, don't await, right? But if then pay close attention. Then this text does commit is what it does is just that it commits this update. So now when a count happens, let's say you created a queue came in and this queue is webhook, right? And it came around 12:54, right? The next queue that is coming in might still be a webhook, what will be updated because it has the same queue will be the count, right? And let's say the next queue that will be coming might not be a webhook, it might be an email, right? It will have to take a new role, right? So now, if for any reason this thing happens and it reaches 1,000, then in the number 1,000, sorry, it reaches 10,000, the 10,001, I don't know if there's anything like that. When I want number, this is what is going to happen. It will say that you have reached this limit. You have exceeded your limit actually. Like you have exceeded the 1,000. We only allow 10,000 people to actually have access to this at a time, right? If it's a city, then it awaits when the result comes out, commit it to PostgreSQL. So committing is just saying that I want this thing to be public. I want it to be visible, right? Already this is not visible, but Postgres have already acknowledged it, right? But committing is making it visible and consistent with what we want it to do, right? We don't want any duplicate or inconsistency in our um, a max number, right? That's why that's why this commit is real extension. So this commit happens even if there is an error. Even if there's an error, it commits that okay, this have exceeded this number 1,001, 10,001. Then anyhow there is now returned. Then if the commit are more rich actually, then it still commits the existing, okay, maybe the number now 9,099 and wait for the return, and then it gives all this. This is just basically what this. So this is kind of a a gate man that makes sure that everything is in order, everything is in order, before it is being um um maybe stored inside our web, inside our PostgreSQL. That's basically what is happening. So I'll try and see if I will actually give over overview of um the other the other data flow, right? I will see if I'll give that for these other data flows. Um, I think I'll give another view of this, and then maybe just taking it one after the other and just be explaining these individuals um one at a time. So, but there is some unique there are some things that actually that makes this tool want to stand out. Right? I get it to have five consistent constitutes or constitution or laws that guide it. Which one of them we have seen is just that this must be debuggable. There must be a reason behind every error, right?